Hello everyone, welcome back to our YouTube channel. In today's discussion, we discuss a very interesting question from the IIT Jam Mathematics 2024. Okay, and this question is from the analysis of ordinary differential equation part. Here in this question, given that alpha belongs to R, means alpha is a real number, and y alpha is a solution of this first order differential equation with the initial condition y of 0 is equal to alpha. In this question we have to verify these four options. In the first option saying that the solution y alpha x goes to 0 when x goes to infinite for every alpha belongs to the real number set, and in the second option is saying that this limit value y alpha x when x goes to infinity is equal to 1 for every alpha belongs to the real number set. In the third option is saying that there exists an alpha so that this limit value is different from the 0 and 1. Okay, and in the fourth option is saying that this limit there is an alpha belongs to the real number set so that this limit does not exist. It is the fourth option. Okay, so before going to verify these options, first of all we have to evaluate the value of y alpha x. What is the y alpha x? So to evaluate the value of the y alpha x, we have to solve this initial value problem, this differential equation along with this initial condition, because the y alpha satisfies this equation 1 and 2. Okay, clearly this equation 1 is a first order differential equation and it is a linear differential equation, and the integrating factor of this differential equation is e to the power 2x. So we multiply the e to the power 2x on the both sides. Okay, then we will reach to this equation. Then in the left hand side this expression is nothing but this one. Okay, so then we will take the integration from 0 to x on the both sides. Then after applying the integration we will reach to this identity. Okay, or equation. Here y0 is the value of the alpha, y0 is equal to alpha. Then we will move to the alpha value on the right hand side, then we will divide e to the power 2x on both sides, then we will reach to this equation 3. Okay, in this equation 3 since our y alpha satisfies this identity also, so our y alpha is value is this one. Okay, then we will take the limit on the both sides, means limit x tends to infinity. We have to calculate this limit. Clearly if one will take the limit value on this term will goes to 0, because e to the power minus x goes to 0 for every alpha. It is independent of alpha, and in this term we have to calculate this limit. Okay, if you observe this numerator and denominator, this denominator is going to infinite, this value goes to infinite. Okay, but we have to ensure that this limit also goes to infinite, because it is a non-negative quantity, and when x goes to infinity one can expect that this integral value goes to infinite. Then we can apply the LH rule. Okay, because numerator will goes to infinite, denominator will goes to infinite, then only we can apply the LH rule. So first of all we have to ensure that this numerator value limit goes to infinite. This is our next claim. Okay, so to verify this we will start from this expression. Okay, and this expression is greater than equal to this. Why? Because in this expression we are taking 1 plus x square instead of 1 plus t square. Clearly our t is less than equal to x, so t square is less than equal to x square. So 1 plus t square is less than equal to 1 plus x square. Then we will inverse this thing. So 1 by 1 plus t square is greater than equal to 1 by 1 plus x square. This inequality is used here. Okay, so we will get this inequality. Here 1 by 1 plus x square is independent of t, so it comes out from this integration. Then after evaluating this integration value we will get this term, and this term is nothing but this. Okay, and this limit is equal to infinite after applying the successive LH rule, because this goes to this numerator value goes to infinite, and this denominator value also goes to infinite, so it is in the infinite by infinite form. By applying the LH rule we reach to this step. Again we will apply the LH rule, because it is also in the infinite by infinite form, so we will get e to the power 2x, which is nothing but e to the power 2x and its limit value is infinite. So we infer that the limit of this expression goes to infinite when x goes to infinite, but this value is lesser than this expression, but this smaller value is going to infinite, so this larger value is also going to infinite. So from this this argument one can infer that this limit is infinite. Okay, then we can apply the LH rule to evaluate this limit. We will apply the LH rule. So applying the LH rule, it gives this. We can differentiate the numerator and the denominator. To differentiate this numerator thing, here we will apply the Leibniz rule. What is the Leibniz rule? Leibniz rule is saying that a derivative of ax, these are ax, bx are some function, f of y dy is nothing but derivative of b dash x b into f of bx, okay, and minus derivative of a into f of ax. This is the standard Leibniz rule. Okay, so here bx is equal to x and ax is equal to 0. So this term will not come, and this value is nothing but this expression and this one. Okay, so it gives this value, and in the numerator it gives derivative of e to the power 2x is 2 times e to the power 2x. See here, e to the power 2x and e to the power 2x get cancelled, and so we will get this term, and this limit when x goes to infinity, this expression limit goes to 0, because here in the denominator x square is coming. Okay, so we will get this limit is equal to 0. So the limit of y alpha x is equal to 0. This is equal to 0 for any alpha belongs to R, because here this limit is independent of alpha. So we are getting this limit is 0 for any alpha. So this option A is true, option B is false, because it is saying that this limit value is 1, and option C is saying that there exists alpha so that this limit is different from 0 and 1, but we are getting this limit is always equal to 0, so it cannot be different from 0 and 1. So option C is also false, and option C is saying that there exists alpha belongs to R, this limit does not exist, but we ensured that this limit always exists and it is equal to 0, so it is also false. So only option A is true. I hope that you all understood it very well. Thank you all.